Good morning. My name is Ravi Kumar. On behalf of Empyrean, I would like to welcome you all today to the webinar on accelerating tapeout with fast layout bring-up, analysis, and debug. During the webinar, you can start entering your questions in the chat window. They will be answered after the presentation. In case we run out of time, we will answer the rest by email. Recording of the webinar will be made available within a day and you will be informed by email. Today's presentation on accelerating tapeout using better chip finishing solutions will be delivered by Jamie Chen, a veteran with 20 plus years of diverse experiences. Starting out as EDA developer, he moved on to CPU design engineer and then into applications engineering. He is well versed in flow planning, place and route, clock tree, and static timing analyses, timing closure, chip assembly, and finishing. Take it over, Jamie.
Hello everyone. Today I would like to introduce one of Empyrean's flagship products, Skipper. Skipper is a layout and a chip finishing tool. As the technology advances, the design gets more and more complicated. We are putting more transistors into a single chip, and we are adding more layers to the design. These are all causing our design data files to get larger and larger. On top of that, the design team members could be located in different geographic locations. All these are posing huge challenges to the engineers using traditional chip finishing tools. It could take hours just to open a large design layout, not to mention if you need to debug any LVS violations that involves PG nets. Skipper is a new generation chip finishing tool designed to work efficiently with these large and complicated layouts. The core engine is the layout viewer with state-of-the-art design data model to provide fast access and efficient memory usage. Based on this efficient layout viewer, Skipper provides all the necessary features from layout integration to fit processing. User will be very impressed from the first step, that is how fast Skipper can open large designs, whether it's GDS or OASIS. First, it uses parallel processing when reading in the design data files to reduce the I/O network speed limitation. Second, it supports incremental loading mode, that is to allow partial design update without having to reload the entire design. Third, it provides a data sharing mode. Once a user opens a design, any additional user can bring up the same design instantly without having to load in from the disk again. Each user can then operate on the design independently. This data sharing mode can drastically improve designers' productivity. One big challenge when assembling a large SoC chip is the IP block merge. For a large SoC chip, IPMerge becomes a very time-consuming task that could take several hours or even over a day. With IPs could come from multiple sources. It is quite often we could have cell name collisions meaning different cells could have the same name. If this issue is not properly resolved, it could cause large number of LVS violations. Skipper provides fast and easy to use chip assembly features. It can mix and match GDS and OSIS file formats. Its largely parallelized layout scanning technology greatly improves the time for loading and merging a design. The trial mode is very useful and efficient for initial naming conflict checking. Without actually merging a design, Skipper can scan for all subdesign names throughout the entire hierarchy and report naming conflicts. Because of data sharing technology, other users can access the merged design immediately without having to wait for the merged design to be written out and loaded back into a server again. Skipper has another very convenient feature to let you add any text info to the merged layout file. You could utilize this feature to add any version-related info, such as IP version and source, library version, etc. Once added, Skipper can very quickly scan for this text info without having to open the layout. Skipper's net tracer is very fast. This is particularly important when you need to trace the PG nets, which will choke most chip finishing tools. Skip Net Tracer supports modern technologies all the way to 7 nanometer. Skip Tracer will not stop you from doing your normal work while it is running the tracing. Since the Skip Tracer is running in a separate thread, you can use Skip normally while it is performing the tracing in parallel. Skipper can load the result file generated by your golden DRC LVS sign-off tool and mark all the DRC violations on the layout, as well as list all of them on the side. When it lists all the violations, it can also list the violations as groups. You can then waive all the same type of violations with one click. You can also fix one cell and all the other instances of the same cell will be fixed. This will drastically improve your productivity. Once you have gone through all the violations, a report can be generated down to the detail of which violations were waived and benefit from its unmatched tracing speed. LVS debugging is an easy task using Skipper. With today's large design size, short tracing could take a long time, especially when you have signal nets shorted with the PG nets. In Skipper, we can trace all the shorts on a PG net with a single tracing operation. This provides a drastic productivity improvement. In the chart, you can see how fast Skipper can trace the PG nets in different design sizes. It is necessary to make sure the edits you made to the design is as intended, and the new version of the layout does not contain any surprises before move on to the next step. LVL is the function that can compare two layouts and display the differences. The challenges of running LVL on a large layout is the runtime and the memory consumption. Once the LVL run is completed, how the results are delivered for the engineer to easily see the differences is also very important. The proprietary data model that Skipper uses allows it to deliver very fast layout versus layout comparisons for large designs. On top of that, it can also run LVL on a sub-area, a selected hierarchy level, on selected layers, etc. This makes it more efficient to run LVL. Why run LVL on the areas you know has not been changed? Once the LVL is completed, you will be able to see the differences in two side-by-side windows with the changed objects highlighted. We have received multiple customers' requests to help generate a LAF with antenna parameters, which are a very important asset for IPs. So we listened to our customers and developed this function in Skipper to support processes all the way down to 7 nanometer. Again, the proprietary data model and the parallel computing have empowered Skipper with very fast runtimes in the LVL extraction. With the latest technology advancement, the layers are getting more and more complicated. Quite often, we need to manipulate the layers for different analysis purposes. With Skipper, these layer operations are very easy and intuitive to achieve. You can add, shift, copy, delete layers. You can perform Boolean operations between layers, etc. On the instance side, you can make edits on a cell and save it either as a local edit, which will cause to create a new cell, or as global edit, which will be applied to all instances of that cell in the design. You can cut out an area and save it as a new cell with all the original hierarchy maintained. We are not trying to replace the full-scale reliability analysis tool here. What we are trying to do is to provide an early and a quick check to alert you of all the potential reliability issues due to high current density. You can place multiple voltage sources and grounds on the layout. Skipper can then quickly extract the resistance numbers for every segment on the net and then calculate the current density on every segment. It will then rank the segments with higher current densities on the top, alerting you the segments that are potential hotspots and might become weak spots for reliability. These are the points I would like you to take away from today's webinar. 1. Skipper is a fast and easy to use tool that can greatly improve your productivity during layout sign-off. 2. Skipper can deliver 3 to 10x speed up for the most time-consuming steps, that is IPMerge and LVL. 3. Skipper can make your layout analysis and DRC LVS debugging much easier. 4. Skipper can help you to reduce your design cycle in the last and the most critical design step and accelerate tape out.